Hello, we're going to talk about volcanic eruptions today and look at the different types of eruptions and how those different types of eruptions make different types of land features. So here's our targets for today. Hopefully by the end of the week you'll be able to explain how the composition of magma affects volcanic eruptions and lava flow. You'll be able to describe the 5 major types of pyroclastic material, identify the 3 main types of volcanic cones, describe how a caldera forms, and list 3 events that may signal a volcanic eruption. That's the goal for this video. And we're off. So number 1, types of eruptions. The type of eruption depends on the type of lava. So here's what you need to know. You can see that these 2 volcanoes here have very different looks. This one's a lot more explosive. This one looks more flowable. And the reason is they have 2 different types of lava. This is mafic lava here on the left and felsic lava on the right. 2 types of lava, 2 types of eruptions. These terms, mafic and felsic, should sound familiar to those of you who are in first semester Earth and Space when we talked about igneous rocks. So mafic lava is rich in magnesium and iron. It's dark in color. And it makes nice quiet eruptions like this one here on the left. Felsic lava is rich in feldspar and quartz, and it's light in color, and it makes more explosive eruptions. So it's more viscous, more sticky, and it holds more gas. And that gas, that combination is deadly. So those 2 types of eruptions, I mean, some volcanoes you can just stand nearby and watch them erupt and you're not really in danger. And some, if you're anywhere in the county, you're likely to be covered with volcanic ash. So, and that is all a result of the 2 types of lava. Now, I mentioned volcanic ash. Anything that comes blasting out of a volcanic eruption is called pyroclastic material. Fragments of rocks that formed during a volcanic eruption is pyroclastic. Pardon me, pyroclastic, and that just clastic means means like bits of broken up rock, and pyro just means fire. So that term should tell you something about it. And then we're going to talk about 5 different categories for that. Volcanic ash is anything that's less than 2 millimeters in diameter, and I've got I might have shown some of you. I've got some volcanic ash from Mount St. Helens eruption back in 1980, I believe. So the ash is quite small. It's like you would see in a, your charcoal grill, something like that. If it's even smaller than 2 millimeters, if it's 0.25 millimeters in diameter or smaller, then we call that volcanic dust. That can travel quite a ways in the atmosphere. Okay, so the heavier stuff, if something that's smaller than 64 millimeters, we call that that's lapilli. That's Italian for little stones. So there's a volcano in Italy, I've forgotten precisely which one, that's kind of notorious for kicking these things out. And and so hence the name is Italian. Lapilli means little stones, they're smallish. Volcanic bombs are blasted from a volcano. They are actually molten while they're traveling through the air. And so they form kind of a round shape, or sometimes they call it a spindle shape, torpedo shape, while they're cooling in the air, and then they land. And then the biggest ones of all are volcanic blocks. These can be the size of a small house. So they're getting blasted out into the sky. Obviously a lot of energy behind that eruption. So there's something that's pushing that kind of thing out would probably have felsic lava. It would cause an explosive eruption. Okay. Now, there are 3 types of volcanoes. That 2 up there just means it's the second category of things that I'm discussing here today. But there are 3 main types of volcanoes. Shield volcanoes. Look at this gentle slope up and down here. It covers a broad area. This volcano is in Iceland. And it's supposed to be kind of reminiscent of Captain America, or really it was Roman soldiers setting their shields down on a table or the floor. You have some broad area that rises a little bit. That's called a shield volcano. So they're broad at the base with gently sloping sides. They form from quiet eruptions, which means that's mafic lava, and they are formed just from layers of hardened lava. Just lava flows out, and if you could drill into this, you would just see layer upon layer of lava that is hardened into rock. Cinder cones are the next kind. Look at that steep-sided, very steep-sided, and it forms from explosive eruptions. So something like this would be kicking off a lot of dust and rock. That dust and the heavier stuff just falls quickly. It doesn't flow, and it doesn't go very far, so it forms these steep sides made of pyroclastic material. So lots of lapilli and volcanic bombs and volcanic blocks there in that stuff. I also find some dust and ash as well. The third type is a composite volcano. This is a picture of Mount Fuji, I believe. Mount Rainier in Washington State is another composite volcano. They're intermediate between shield volcanoes and cinder cones. What I mean by that is that they have layers, alternating layers of lava and pyroclastics. So you'll find that they might have explosive eruptions or they might have quiet eruptions. And the same volcano could kick out both, depending on what type of lava, the chemistry that's going on underground here. So these are kind of the picturesque types that most people picture. They picture a composite volcano when you're imagining a volcano. Okay, next term to know is a caldera. And the question is how to form a caldera in 3 easy steps. Here it is. You start off with some typical magma chamber underground, and it's forcing that magma up to become lava and forming a volcano. The volcanic eruptions partially empty the magma chamber, and so you've got a magma chamber that this big voided space here that's now empty of magma, and then the mountain on top kind of collapses down inward. So it's a large circular depression that forms when the magma chamber below a volcano partially empties and causes the ground above to sink. These kind of can form remarkably beautiful scenarios, situations, scenes. This is an image of Crater Lake National Park. It's one of the most beautiful parks that I have not been to. I would love to go. This is in Oregon, and that this is an enormous caldera that has filled in with water. So this had been a volcano that was rising up into the sky, and the magma chamber down below emptied, and the whole volcano kind of collapsed in on itself and then filled with rainwater. And so this water, I've seen pictures of boats on it, and it just looks like the boats are floating in the air. The water is so crystal clear. It's remarkable. And then you get a little island here. This might have been a few volcanic eruptions after the caldera formed, something like that, but strikingly beautiful. Okay, section 4 is predicting volcanic eruptions. This is the last section. And there are a few clues that indicate when a volcano may erupt, and we're going to focus on 3. So if you're living near a volcano and there's an increase in earthquake activity, that is a good sign that that volcano is becoming more active and may begin to erupt. It's also possible that the rock temperatures may increase on the volcano itself. So many times the U.S. Geological Survey will, if there's a volcano that's considered active, which means that it's not necessarily erupting this minute, but it has the potential to, they can track the earthquake activity, and they can track the rock temperatures as well to make predictions about when it will erupt. At last, pardon me with all my yawning, I'm filming this quite late, and I wake up quite early. The volcano's surface may actually begin to bulge. So as pressure builds, this is probably not something you would notice just with the naked eye, but with the right tools, you can detect the sides of the volcano actually bulging outward. And something like that would indicate, again, that a volcano is likely to erupt soon. That is it for the bare essentials that you should really be exposed to about volcanic eruptions. Now, go be awesome.